Hi, I'm Ryan Nickel, CTO at DSA Ocean, and today I want to show you about adding active stabilizers to your ship models in ShipMo3D. We're going to use one of the sample projects that uses active stabilizers on top of the generic frigate, and this is actually one of the sample cases you can download from from the ShipMo3D website here. Now, setting up the generic frigate ship model with stabilizers is exactly the same process as the generic frigate. We'll go to ShipMo3D and open the existing project. I've already gone through the steps of adding panel hull, panel lid, and rad diff information. So the last step we're going to do here is just select build ship, and we'll pick stab fin gen frig project, build ship, and we'll open that one. And we'll just make sure that we're selecting the rad diff database and the dry panel hull files here that we created previously. Now the only difference, basically the only difference between this and the regular generic frigate model is that the stabilizer fins have already been added with their properties. And you can see the properties listed also in the validation report. So the validation report is the ShipMo3D validation report is downloaded off the ShipMo3D website, and we're looking at case number 9 here, verification for a frigate with stabilizer fins. And the stabilizer fin properties are here. These are already laid out in the stabilizer fin properties here. So there's not much to change in terms of the inputs. So we'll go save and run to assemble the numerical ship model. And note that if you go plot ship, let's just pivot the ship model here. You can see the little stabilizers right in the middle, right here and here. So they start off with some dihedral angle. And how they respond is going to be largely governed by the control parameters here. You can see the only thing that's specified here is in roll velocity gain. So that kind of gives an idea of how much they're changing their angle of attack to resist that roll motion. So how do we evaluate the performance? And maybe we might even want to adjust these or adjust the size of these stabilizers or the control coefficients. We should expect to see similar results to the attenuation of roll in the verification at 10 knots in regular seas. So without the stabilizers, we're getting just below an RAO of 3, and then with them, it's just a little bit above 2. So let's see what happens. So we're going to evaluate the roll RAO by using CKeep regular, and we'll use the CKeep regular project that's there. Let's make sure we're using the right ship motion model or pointing to the right file in our project folder. And we'll just go save and run. So we go plot motion RAO 10 knots at 90 degrees. You can see our roll RAO. We've got just a little bit over 2.3 roll motion. So we're seeing them have an effect. And then you also can see things like the RAO response of the stabilizer fins down here to see that they're actually doing something. So really quick characterization. The really nice thing is, again, this is an additional viscous model added to the ship model. You don't have to go back and reevaluate the radiation and diffraction loads. Those are just a function of the ship hull form itself. So we can change these parameters, change the control coefficients, change the size of them, add more of them and see what happens to the ship motion really quickly as a result. So the RAO is just the first step. You can see what this does in an irregular sea state response or time domain response as you want as well. Thanks for watching.